Muti, I'll teach now, okay? Hi, Adam.
Hello, sir.
You're already here. Are you there?
Yeah, I can hear you. Yeah, yes, sir. So you can hear me?
Okay, hold on. I think my speakers are off.
Bluetooth mode.
Hello?
AUX mode.
Okay.
Yes, sir.
All right. There, I can hear you now. Yeah, I could see you, but I can't hear
yes.
you. So, all right, now I can. How are you today?
I'm good, sir. How are you?
Doing good. Doing good as well. Thank you for asking. Okay, so, all right. Quick question: when are your mocks?
My physics mock is next Friday. So
Next.
not the week after. Next week, so 24th.
Oh, on the 24th. All right. In that case, we still have a bit of time. Do you have any? You have any materials with you that your teacher's given to you before, or not?
I have a GCSE book that I used to study.
Oh, okay. Is it possible for you to share that?
What the book?
Yeah. Hold on. I think. Yeah, never mind. I got a few past papers here again. This time from, if I'm not mistaken, here. When was this? Let's see the date. 2021. Not quite recent. You want to go through this?
Okay, sir.
All right. Okay. Well, of course, Adam, later, if you want to go through the material your teacher gave you, just let me know and we'll do that. Okay?
Yep. So I already covered the material with this revision in the past papers.
All right then. Okay. So, oh, by the way, you're allowed 1 hour and 45 minutes to finish this, right? There's 100 marks. That's basically you should answer each question with a time of 1 minute per mark to give yourself 5 minutes to do anything else. Yeah. Okay, so maximum of 1 minute per mark. All right. So here's the first question here. The thinking and braking distance of a car vary with the speed of the car. So explain the effect of two other factors on the braking distance of a car. Do not refer to speed. So two other factors that can affect the braking distance of a car, and what does that do? Okay, we're only talking about braking distance, not thinking. Okay.
I'm just figuring out how to work it out.
Okay.
How do I perfectly answer it?
Okay. Okay, I'll give okay, what do you have so far? We can work from there. Just what do you have so far?
The car's speed, like I'm just listing points and then putting it into a highway. So the factors that have affected is the car's speed and the distance between the object that I'm like why I'm braking.
Mm-hmm.
Pretty much. But I'm still figuring out a good answer.
Okay. Alright, so that's a good start. You need a bit of help, or you want to try to figure this out first?
Please charge.
Sorry about that. My speakers say it's low battery. I think I'll change to headphones first. Hold on. Okay, I'm on headphones now. Can you hear me? Alright, Adam, can you hear me now?
So if you're talking, I can't hear you.
Ah. Okay. How about now? Can you hear me now?
Yep, that was it.
Okay. Hold on, I'll just try something else. Okay, is that better?
Yeah.
Okay. Alright, okay. So, what would the answer here be?
But I haven't done really like. I know it's an easy subject, but I did this a long time ago, and I haven't
Yeah.
really studied this because it wasn't in the topic list that the school gave us.
Ah, okay. So here's the idea, yeah. You said something about distance, about speed, right? The best, but unfortunately here we can't really use speed, right?
Yeah.
Because of what the way the question is asked. So, okay. So the idea here, the best way to go through this, let's see the examiner report real quick. Okay. Now, okay. So first of all, this is a 4-mark question, so you need to identify 2 things, and then you need to explain why those 2 things affect the braking distance of the car, right? So the first one I'm gonna put here is road conditions.
Actually, I have some points. I listed down some points.
Okay, go ahead.
Yeah, poor road surface or road conditions.
Okay.
Poor conditions of the tires.
Okay. Tire conditions, correct. What else?
Worn out brakes.
Worn out brakes. Yep.
Because of the decreasing friction.
Okay. Anything else? All of these basically are for decreasing friction, right?
Yeah.
Okay. Friction decrease.
And I have other ones such as the mass of the car.
Okay.
Maybe the passengers.
Correct. Okay. The other one, as you said.
I have an explanation for that.
Go ahead.
If that could give any more marks.
Okay. What would that be?
That increases the kinetic energy of the car.
Correct. Now, which one would I go with?
I guess it has more work.
Okay. Okay, so you have to explain here if you do energy, right? Increased energy, increased kinetic energy. You're gonna have to say okay. If you use the kinetic energy, you're gonna have to say that more work is needed to stop the car, right? More work needed to stop the car. Okay, the other possible answer, as you said, is increased momentum, right?
Yeah.
Okay, so what do you have to say here? More force needed to stop the car. Okay.
Yeah.
All right, great. Actually, from what I understand, this would have been enough, and then stating one of this would have been enough. Okay, because of the fact that you have to say 2 other factors. Okay. All right. Good. So let's go to part 2 of this question. Okay, here. Which equation links acceleration, mass, and resultant force? Tick one box. I think you should know this by heart now.
Resultant force equals the mass times acceleration.
All right. Okay. Alright, so let's tick that. Mass times acceleration. That's correct. Okay. The next question. The mean braking force is given and the mass of the car is also given here. You need.
Sir, I have a question.
Go ahead. Go ahead.
Is that in the physics equation sheet?
I think this is. I gotta double check that, but I think it should be. Hold on, let me double check. Real quick.
I'll solve it while you.
Okay. I'm just gonna go straight to the equations. Hold on. Yes, it is. It's on the second page.
They don't have like I don't like sit and waste more time like memorizing formulas.
Yeah, I wouldn't really seriously. I wouldn't memorize formulas. I'd rather get the concept, right? So try to memorize the concepts. All right. Okay, so the third question is here. The mean braking force is 7,200 newtons, and the car has a mass of 1,600 kilograms. So calculate the deceleration of the car.
4.5.
Okay, how do we do that? Just show the working, right? Because it's 3 marks.
It's so 7,200 equals to 1,600 times acceleration.
Correct. A. All right. And then from here, just work
So
out A.
if you rearrange, you divide 7,200 by 1,600.
Okay, correct. And then A, you'll get the final answer.
4.5.
4.5. Now, in this case, it already says deceleration. You have to state. You don't have to put the negative in. Okay? You can keep it as positive. It's okay. Now, one more thing. Don't forget the unit. I think the reason why this is 3 marks is you need to state the unit.
Yeah, I thought the unit was already stated in the question.
Not quite yet. See? Newtons for force, yes. Kilograms for mass, yes. But deceleration, no unit yet.
Could you try like go back to the past?
But if it, oh yeah, let's take. Yeah, you got a good point. Past paper itself already is given. So yeah, the number's good enough. All right then. Okay, let's move on. You're right. Okay, let's zoom out a bit first. So we have this graph about the thinking and braking distance vary with the speed of the car, determining the stopping distance when the car is traveling at 80 kilometers per hour. Okay, that's 2 marks. So, how would you determine the total stopping distance?
I just need you to please like zoom in into the graph so I can see exactly
Here we go.
where 80 is. Yeah.
Okay, I'll zoom in a bit more. There you go. I'll share these papers with you as well later in the chat box, okay?
Okay. Yeah, I got it.
Okay, what's your answer?
53.
Okay, how'd you get 53? How do you get 53?
The thinking distance. Thinking. So the whole stopping is thinking plus braking.
Correct.
So it would be 80 would be 15.
Mm-hmm.
And braking would be 38.
38, correct.
Roughly 38.
Yeah, we can put it at 38. I think it's close
No,
enough.
it is 38 because it's by 2.
Uh-huh. It's 38, right? So 38 plus 15, correct. 53. All right. Next question. We have this. We have part. Oh, this is about pressure now. Like you said, you didn't study pressure yet, but we might as well. We might as well, just because it's a simple concept, right? Okay. So, figure 2. Okay, we have figure 2 showing the forces, the brake on the car rather. Okay, Which pressure links the surface normal force to the surface and pressure? This is also in the equations book or the equation sheet. So you don't really need to memorize this.
Oh yeah.
You found it. So
E
what's
equals to F over A.
correct? So P equals F over A. There we go. Next. Okay, when the brake. Okay, so here we are now. The brake pedal is pressed, a force of 60 newtons is applied, and the pressure is this much. Calculate the surface area in standard form and the unit. This is a lot of marks. So what would be the marks? One would be final answer in standard form, one would be the unit, and the 3 would be the working. Okay.
Just give me a few minutes.
All right.
Okay, I got it.
All right, what's your answer?
My answer is 5 times 10 to the power of negative 4 meters squared.
Correct. Okay, again, let's just go through the working just to be sure, yeah? So, how'd you do it?
So I start with 120,000
Equals?
equals to 60 over 8.
Okay,
Using
correct.
The formula which we
Correct.
last question.
So, finding the area, that would become?
A would be 60 over 120,000.
Correct. Then,
Equal
just
to
solve for it, right? That,
0.0005.
okay, area is that. Square meters.
One more zero.
Oh, one more zero here, right?
There's one more zero.
Okay. And then, from here,
So the one in standard form, so you can add to 5 times 10 to the power of negative 4.
correct. Okay. Now, okay, I think this is good enough for the answer, yeah? So let's move on. Okay, great. No questions here. Okay, this is now springs. Okay, so you've learned this before, so let's go through let's go through this. So what do you mean by elastically deformed?
Means that it would go back to its original shape or length.
Mm-hmm. That's 1 mark.
Okay. When the force is removed.
There we
the
go.
girl is off the...
Okay, that's correct. So you have to refer back to the fact that you have to remove the force. Okay, so when the force on the spring is removed, it goes back to its original shape. Okay, so let's move on. Second part here would be okay, hold on. Here. Okay, so you have the investigation here. You have a graph. Figure 4. This figure shows the results of the graph of the investigation. So describe a method. Okay, I think I'll put this in the Jamboard so it's easier to read.
These questions.
Graph questions. Why? It requires math.
I have to know the one I have to like create a full. I just have to create a full like plan.
Yeah. I can see why you hate this. This is 6 marks. Okay. Okay, I'll just put this here on the Jamboard so it's easier to go through. Okay. So I'll just put the graph back on the screen, yeah? Describe a method the student could use to obtain the results given. Again, since this is 4 marks, 5 marks would go into the actual procedure and 1 mark for the hazard. By the way, Adam, I do appreciate your mom, yeah? Not for me, but I appreciate your mom for you. She's really supportive of you.
Ah, thank you, sir.
Alright. Yeah, keeps booking lessons and keeps asking for updates. I wish all the other parents of students I teach online are like that.
Thank you, with her.
Well, if you want to let her know, you can let her know. Alright, so what do you have so far?
Okay, I got something.
Okay.
So you set up a lamp, a clamp stand with a lamp.
Okay. One, set up.
We've done this question before, though.
Yeah, we've done this exact question before, right? Yeah, if you... I don't know why...
Realizing it.
Yeah, I just wonder if they actually do this on purpose. Because this is the second paper, like, in
They
like...
never change the questions for new papers.
Yeah, that's true enough. Alright, set up a clamp. And then 2.
Hang a spring from the clamp.
Hang a spring from the top. Okay. Then
You could use a second clamp to hang a meter rule alongside the spring to measure.
okay. Clamp to I'll just say it in another way, but yes, that's correct. To support a meter rule. Okay. Number 4.
Measure the length of the spring. Measure the length of the ruler from the bottom of the spring.
Okay. Measure the... I think it's better to say it in a different way, but I get your idea. Okay, I will ask you to use the word take a reading.
I would say it different. Record the ruler reading.
Okay,
Yeah.
take a reading of the ruler where the bottom of the
ruler.
bottom
The
of
bottom of the string. Sorry.
spring is. Correct. Okay. Next.
Hang a 1 Newton.
1
Hang a 1
Newton.
Newton. Wait.
Wait, okay. On the spring, right?
At the bottom of the spring. Yeah.
Let's put that bottom of the... Okay. Now, next one.
And then now record the position of the spring.
Record the new position. Alright, great. Position of the spring. Okay, and then finally,
And you calculate the extension of the spring.
okay. Okay, and then
And then repeat the same thing, the same method from 1 newtons to 5 newtons.
for 1 Newton to 5 Newtons. Okay. 3. Hazard, risk assessment for 1 hazard.
And for each measure the extension. And for each measure the extension.
For each value measure. Okay. Risk assessment.
The spring could break. I mean, I don't know how to say like what will happen to you if the spring would break, but